Part 4. The parts of artificial intelligence. AI is made up of 4 parts: reasoning, natural language processing, planning, and machine learning. The first part of AI is reasoning. Just think of this as the machine making conclusions using information or data, the same way humans think and reason. Computers use algorithms or a set of rules which are applied when solving a problem. These algorithms imitate the simple, step-by-step reasoning that humans use to solve problems and make logical conclusions. However, humans are not computers, and we do not always think logically. We actually solve most of our problems using fast, intuitive judgments, unlike computers who use algorithms. The second part of AI is natural language processing, or NLP. This gives a computer or machine the ability to read and understand human languages. The third part of AI is planning. And as we know, a plan is a strategy to achieve something, and you need a plan to reach a goal. This is the same process taken when creating an AI program. The computer must have the ability to construct a sequence of actions to reach the final goal. The fourth part of AI is machine learning. And machine learning is when a computer system is fed large amounts of information or data, which it then uses to carry out a specific task, such as understanding speech or labeling a photograph. Machine learning happens after a goal or target is defined. The steps to reach that goal are learned by the computer, which trains itself. For example, to identify a simple object such as a banana or an orange in a picture, we would feed many different pictures of bananas and oranges into the computer. It is just as we teach a child by showing multiple different pictures of it, therefore allowing the machine to define the steps to identify it as a banana or an orange. Machine learning is generally split into 2: main supervised learning and unsupervised learning. But there is also a third form of learning called reinforced learning. Let's push on and learn about supervised learning, unsupervised learning, and reinforced learning. What is supervised learning? A common technique for teaching AI systems is by training them using a very large number of labeled examples. These machine learning systems are fed huge amounts of data, which are marked to highlight the features of interest. Once trained, the system can then apply these labels to new data. For example, when new photos have been uploaded, the machine can identify a banana within the photos. Training these systems requires a vast amount of data. Some systems need to be fed and examine millions of examples to learn how to carry out a task effectively. Datasets for training systems are very large in size. Google's Open Images dataset has about 9 million images to train AI systems, whereas YouTube has links to millions of labeled videos. In the long run, having access to massive-sized labeled datasets may also prove less important than access to large amounts of computing power. In recent years, generative adversarial networks, or GANs, have shown how machine learning systems that are fed a small amount of labeled data can then generate huge amounts of fresh data to teach themselves. This approach could lead to the rise of semi-supervised learning, where systems can learn how to carry out tasks using a far smaller amount of labeled data than is necessary for training systems using supervised learning today. Now let's look at unsupervised learning. What is unsupervised learning? Unsupervised learning uses a different approach where algorithms try to identify patterns in data, looking for similarities that can be used to categorize that data. The algorithm is not set up in advance to pick out specific types of data. The machine simply looks for data that can be grouped by its similarities. For instance, a good example of this are news feeds, which group together stories on similar topics daily. Now let's look at reinforcement learning. What is reinforcement learning? This is very similar to supervised learning. But the main difference is that the machine does not learn off a set of data, but rather a series of trial and error. This type of learning is used in game development. On each successful game, the machine learns to keep doing certain moves. Take, for example, a puzzle game where the machine learns it must click red before blue. Once the machine learns this, it will always click red before blue. It is important to note that deep learning is considered an evolution of machine learning. The main difference between machine learning and deep learning is the way that data is presented to the system. Machine learning algorithms require structured data and human intervention, while deep learning networks rely on the layers which exist within the neural networks and do not require human intervention as it learns through its own errors. In this diagram, you can see how AI, machine learning, and deep learning are all related. So now you understand the different types of machine learning.